All right, GAC Pre-Cal 12. Hope you're having a fantastic day today. I want to apologize first with the weather and everything going on. I know that, having three podcasts in 3 days is not ideal for math, but with the funeral coming up and with the change in schedule, unfortunately, we're dealing with that and trying to be flexible with that. Continue to stay up to date with the schedule. I'll continue to text things out in regards to what the expectation is there. If you could, also sign up for Remind 101 in this bottom corner here. Check that out. That way, if I update anything and I have to text it out, you're on the database that I could get that information to you. As I look at the schedule, again, this will be posted tomorrow morning. You want to make sure you finish 2.1a, 2.1b, and 2.2a. These homeworks, you've already should have done two of those. The only new one is the 2.2a homework, which should prepare you for the quiz. So again, the quiz would be Monday, so just a heads up on that. You, because of the fact that we've had three podcasts for lessons, I'm going to try to be flexible with how I quiz over this. So we're going to do a quiz on Monday with notes. Also, this quiz will be given after a 20-minute review at the beginning of class. So you want to make sure you can kind of view that. Just be familiar with that going forward. I may do a study session. If that's something that you're interested in this weekend in preparation for Monday, just contact me, text me. And if I get an overwhelming response in regards to the need to do another podcast, this one would be a study session where you would log in, and it would be specifically for Pre-Cal 12. So if that's something that you're like, Coach, I really would like to do that, that might be something too, that may be something too that we could do together. Again, contact me in the traditional spots here, and then you are watching the podcast section 2.2b, which should be at the top of the topics page. So I appreciate you for doing that. But again, just go through the schedule and we'll rock and roll from there. What I wanted to do here is kind of use the homework off 2.2a and parts of that homework to be able to address some of the questions that you may have on section 2.2. On the Cyber Day from yesterday, you'll notice that I didn't have you actually do the homework for 2.2. I just had a podcast over it. So if you're starting on this and you have not watched the 2.2a podcast, I would first start off by doing that before going to this, because you may be confused on some of these questions unless you do so. Okay. But just kind of going into this, I'm going to do 2 or 3 of these questions and go to maybe 1 or 2 additional questions after this. And following that, again, that will be kind of the conclusion of this podcast here. So let's start with number 3. We're building off of the concepts we talked about in Cyber Day, Day 2, off that podcast. So we're going to go into that. So let's go step by step, and let's start with part A, okay? And I'm going to actually, sorry about that. I'm going to actually move this to where kind of have a little bit more room. I'll kind of work in this area here. First question says this: find the real zeros of the polynomial function. Remember that the real zeros of the polynomial function mean that we're finding the x-intercepts, okay? So if I'm finding the real zeros, that's really what it means. It means I'm finding the x-intercepts. So before we do anything, we're going to do that. So we're going to say y is equal to all of this. This is the polynomial. It's already factored pretty much for us. So what we're trying to do now in x-intercepts is we plug 0 in for y. So we're going to say 0 is equal to 5x times x squared minus 2x minus 1. Now, since it is already factored, we can set both of these equal to 0, to where 0 equals 5x. And I'll put the second one over here. 0 is equal to x squared minus 2x minus 1. Okay. So as I divide by 5 here, x is equal to 0. So the point of this is 0, 0. Okay? 0, 0. So we've got that first check right there. 0, 0 is the first 0 from this polynomial. The second one is we're trying to solve for x, but because of the fact that there's 2 x's, we can't solve it like we would normally by getting everything to one side and then getting x by itself. So we have 2 options. We can either go factoring, which is what I start with first, And then if I get stuck there, I always use my quadratic formula rather, okay? So I start with factoring. Are there two numbers when multiplied that get me -1, but when added get me -2? Well, the only factors that multiply to -1 is -1 and 1, or 1 and -1. And when I add those together, you'll notice that it can't equal -2. So we go to the next part, which is using the quadratic formula. So in doing this, we say x equals -b plus or minus the square root b squared minus 4ac all over 2a. So when I plug in -2 in for b, I get minus -2 plus or minus the square root of -2 squared minus 4 times a, which is 1, and c, which is -1, and then all over 2 times 1, or 2 times a. So now we just simplify. That would be +2, -2 squared is 4. -4 times 1 times -1 is +4. Okay, again, I'm doing PEMDAS. Make sure you do the squared first. Then I multiply, and then I can add. So on the top, I get 2 plus or minus the square root of 8 all over 2. So to find the actual x-intercepts, by the way, you could actually simplify this radical and then divide them all evenly by each other. But it did say to actually find the x-intercepts. So we're going to go to second quit, and we're going to actually do this step by step. So we're going to say 2 plus square root of a, press enter, and then I divide that by 2. So I get 2.41 as my first one, and then I go to my next one. So 2 minus the square root of 8. Do that because I have a plus and then I have a minus. I divide that by 2 to get -0.41. Okay, so -0.41, 2.41, and -0.41. And then we do put comma 0 because, again, these are x-intercepts that are there. So we have 1, 2, and 3 x-intercepts. So we've done part A. Okay, this is a little bit different. Again, if we could factor, then set them both equal to 0. That's what we would do on part A if we could. But you'll notice that we couldn't factor, so that's why we use the quadratic formula. Now the next part says determine the multiplicity of each 0 and the number of turning points of the graph of the function. So the multiplicity, if you remember before, is the amount of times the 0 is repeated. Well, as I look at this, this specific example, since I have one of each of these, we would say that the multiplicity of 0 is 1, okay, because it's only repeated once. Multiplicity is 1 here, and again, I usually just put an M, and multiplicity of this is 1 as well. Remember we talked about the other day how if the multiplicity is odd, that means at these zeros on my x-intercept, it will go through that point. If it was even, it would touch and bounce. It'd be like touch and then get those hops going. Kind of like Coach J's hops, okay? So because of that, and I've got some hops, okay? I used to dunk. No short jokes there, okay? So because it's odd here, we know that it's going to go through at 2.41 and -0.41 because the 0 is only repeated one time, okay? All right, so again, we've got that. We're good to go there. The next thing says is what is the number of turning points of the graph of the function? Well, the highest degree of this, if I were to distribute this variable, or this 5x, we would get 5x times x squared, which would be 5x to the third. So the highest degree is 3, or the highest exponent, right? Because degree is highest exponent. And we saw something yesterday, and I'll come back to this. Let's see if it goes. I think it's on this one. We said that the number of turning points, or the number of extrema, is n minus 1. So what that means is whatever the highest degree is, we take 3 and we subtract by 1, so 3 minus 1. So the highest exponent, or the degree of the polynomial, minus 1, is 2. So there will be 2 turning points, or 2 maximums or minimums, right? That's what we're talking about. So 2 turning points that are there. It then says use a graphing utility to graph and verify the answer. So simply we're just going to come here and we're just going to plug it in. So we're going to go 5x squared. And again, this teaches just a bunch of different things that we're looking at. We're just verifying it through this. So just put it in just like I see. I'm going to graph it. Now, it may look weird. If it looks like this, that's okay. Go to Zoom, and I always try to go to either Zoom Standard, Z Standard, or I like Zoom Fit, because a lot of times it will fix it there. It still doesn't. You'll see right here, it's still not quite there. You can't really see where it hits the x-axis. So let's go to Zoom Standard. So I'm going to go down to 6. Press Enter. Let's see if it hits it. Yeah, sure does. So as we look at this here, you'll notice that it's going to have 2 turning points, one here and one down below. We can actually zoom out just a little bit more. So we're going to zoom out and then go down and to the right. See if that helps there. Yeah, there you are. So it hits, goes through once, twice, and then 3 times. Notice that each of the zeros it goes through because the multiplicity has the multiplicity is odd for each of those 3. So that's why it goes through. It has 2 turning points, one up here and one down here, which follows the same thing that I had showed within this value. So the expectation at this point is being able to answer the questions that are being asked there. These are a little bit tougher because it's all inclusive, but again, that's why we want to make sure we go through it together there. Okay. All right, let's continue. Let's go through another one here. The one I want to do last is number 4. Let's see. Okay. Okay, so let's look at number 6, and then I'm going to go to number 4. Number 5, we should be okay on that. I can always come back to that in a study session. But I'll do 6, 4, and then I'll go to another one there. Okay. This one says to use a graphing function to be able to graph the expression here. So we're going to graph this first. Okay. So we're going to put parenthesis 1 divided by 4, close it. And then I'm going to go x to the 4th, x, and then that caret, 4th. And then we have a minus 2x squared. So we'll go minus 2x squared. Be sure that you follow the instructions because some of these, it's going to be very hard to do it by hand. This one you probably could still do it by hand, but it makes it a little bit easier if you do it by graphing calculator. So you see it kind of come down, come back up again, touch, and then come down and come back up again. So to help us with this, let's go to the zoom function. Go to Zoom Fit, try that first, see if that will go. Again, it doesn't really give us a clear picture, so I like to go to Zoom Standard. It's kind of my next go-to. And there you are. That's a little bit easier here. So it goes down, up, and down, and back up again. Notice that the highest exponent, remember the lead coefficient test? You could see that on the previous podcast, but the lead coefficient test, which you don't have to do here, but I'm just trying to help you with this, tells me what is the, first of all, the lead coefficient is positive. It's positive 1/4, right? We're looking at the highest exponent, what goes with it. The degree of this polynomial is even, because notice that the highest exponent's to the 4th. So we're looking and seeing what is happening to my end behaviors when the lead coefficient is positive and the degree is even. So I come over here and I notice the degree is even right here. And when the lead coefficient is positive, both rise to the right and rise to the left. Okay, so bless me. Woo. So again, we're going to rise right and rise left, based upon the lead coefficient test of the lead coefficient being positive and the degree, or the highest exponent, being even. So I come back over here. You'll notice that this, in fact, does rise to the left and rise to the right. So that follows through with what we're looking at there. Now the question becomes, what are the zeros here, here, and here? So to help us with this, we're going to go to second trace, And to find the x-intercepts or zeros, we go down to 0. And when we could talk about left bound and right bound, the question is what 0 are we looking for? So we'll start with this one here. So when we go left bound, we want to go to the left or above it. Press enter. When it says right bound, we want to go to the right or the low part of that. Press enter. And then when we say guess, we'll go somewhere in between. And when we do that, we get negative 2.83. So this one, 0 is negative 2.83. All right, so we'll stop there. Let's go to the next one. Let's go to the next one. So we're going to go to second trace again, go down to 0. I think this one is going to be 0, but let's just see. So, so we go, right here's the 0. We're going to go to the left, press enter. We then go to the right, press enter. Again, left bound, right bound. When we guess, we go somewhere in between. And it might have frozen on me. Let's see here. Let's try this again. I think it might have frozen on me. Let's try this again. So we're going to go left bound. Actually, it might not have because you'll see why in a second. Right bound. And guess in between. And the 0, actually we're good. The 0 is at 0, 0. Or we just say we're just taking the x. So the x-intercepts are at negative 2.83 and 0. Let's do our last one because we do have one more, which is on that right side. So go back, second trace, go down to 0. Left bound will actually be the lower portion because it's to the left of this 0 right here. So anything left is below it. And then it'll ask right bound, right down here. You got to press enter there. And then the guess is somewhere in between in that way. And so we get 2.83 positive as that 0. Now the question is based upon this expression, what is the multiplicity of each 0? So in going to this calculator, you'll notice that since it goes through this negative 2.83 and it goes through 2.83, that both of these will have a multiplicity that is odd. Well, think about it. If the exponent is to the 4th, that means we have a possibility of 4 zeros. Doesn't mean we are, but it has a possibility. So that means that these are going to have a multiplicity. It's going to have a multiplicity of 1. Both of these. Because of the fact that at the graph, they go through at negative 2.83 and positive 2.83. Therefore, the multiplicity of both of these will have to be a value that is odd. Therefore, it will have to be a value of 1. If it was 3, that would exceed the possible zeros since this polynomial is to the 4th power. So that's why it's got to be to the 1st. Now, come back to 0. You'll notice that it bounces and returns. Notice the bounce and return. Therefore, the multiplicity of this one must be even. Well, if it's even, it can't be to the 4th power because that would exceed, because you'd have a multiplicity, you'd have 1 0, 2 zeros, and if I did it to the 4th, that would exceed this. So that means this is going to have a multiplicity of 2. Okay, multiplicity of 2. And so that's how you would use a calculator to determine what each of the multiplicities are there. All right. Let's do this last one here, and then we'll go to some new ones here, and then we'll rock and roll. All right. Appreciate your help. Hopefully this will help you with your homework here. Let's do 4x to the 3rd, and then we'll do plus 4x squared minus 8x plus 8. And we're going to graph this, okay? See if it will come up. Kind of does. It kind of goes up there. So let's back up just a little bit. Let's go to zoom fit again. Let's see if that will do. If not, we'll come back. Zoom fit. Yeah, it kind of distorts what's in here. So let's kind of do this just to help us out. Let's go zoom in. Let's zoom in just a little bit. That still doesn't help us, does it? Because the way that they have this is just a little weird. So let's go zoom standard. And again, sometimes you have to tweak it just a little bit. And let's just blow this up right here. Let's zoom out here. So go to zoom, out. We're going to put that cursor just above there and see if that will help us. Yeah, so as we look at this polynomial, we see that it only crosses the x-intercept one time, okay? So because of that, since it only crosses once, we're going to find that 0 by going to second trace, going to 0, and when we see this here, this is going to be a little tough. Let me zoom, let me do this. Let me go to zoom standard again. We see this x-intercept a little bit better here. So when we go to second trace and we go to that 0, we want to make sure that if we're finding the 0, it is to the left or below the x-intercept. So we press enter there. We then go to the right, which is somewhere above the x-intercept. We press enter, and then we guess somewhere in between. And the 0 then, don't worry about this, that's close to 0, that's fine. This would be negative 2.27. So this 0 here would be negative 2.27, okay? So in order to kind of do this, we just did part A and part B in finding that x-intercept. Now it says set y equals 0 and solve the resulting equation. So we're going to say, okay, 0 is equal to this. Let's see if we can factor this, and just to show from an algebraic side. To do this with 4 terms, we use grouping, and we say in the first 2, can I pull out anything? And I think we could pull out something in common, which is a 4 and x squared. So we pull that out. We say what's left over on the inside? Well, we're left with an x, and we're left with a plus 4. Okay, so we got that there. And actually, I want to make sure of something here. And it actually wouldn't work there on this. I'm trying to see what would, and I don't want to take it further if it's not going to, yeah, because I don't think we'd be able to actually group together here. Actually, I think we could. Let me backtrack. Before we do any of this, before we start grouping, is there a term that we can take out that's in common? I'm going to try this. If it doesn't work out, then we'll cross off C. But this is, again, just kind of a good reminder. There's not one like this on your quiz, but the topics of A and B, except the topics of A and B and using your calculator to find the x-intercept. Part C is a little different. It's kind of getting ahead. But let's do this. Let's pull out what's in common. Pull out a 4. So we're left with x to the third plus x squared. Taking out a 4 from all of these is a GCF, minus 2x plus 2. I think that might be a little bit easier, because then we could say out of these first 2, can I take anything out? Well, I could take out an x squared, leaving me with x plus 1. And the question of can I take anything out of these next 2? Well, I could take out a negative 2. And when I do that, I am left with x minus 1. Actually, that wouldn't work because of the fact that these 2 were not the same for grouping. Tell you what, with C, cross that one out, keep that out. I'm not as concerned with that. You could technically use this, divide it out, and go from there. But for right now, we're going to cross off C, because that's going to be more than what we're asking for both the quiz and the test. We'll do that in other units to come. So just as long as you did the graphing calculator on that, I'm good to go. If there was a factoring one here, that would be much easier. This right here, this one's one where you could factor, and you could actually draw this. We know that it's x squared, so we could expect that to be a quadratic with the negative. This would go downward there. So you could actually use the lead coefficient test. What is the degree? What's the lead coefficient? Is it positive or negative? Is the degree even or odd? Tell me what the end behaviors of that is. Is it rise left, fall right, rise left, fall right? Whatever the opportunities or whatever the lead coefficient test tells you, do that and then find the zeros from there. But this can be factored by, you could actually factor that one out. So that's a little bit easier on that one. This right here, again, you should be able to find the zeros. We've done that pretty extensively throughout. The one that I wanted to finish up on is find a polynomial function that has the given zeros. This one is one that just want to make sure that you know how to do. And I think they want this in standard form, so we're going to expect that it is in standard form here. Now, a lot of times when I say, okay, x plus 2, x minus 1, x plus 3, what are the zeros of the polynomial? Well, you remember that you just simply set all of these three equal to 0 to say that the x-intercepts are -2, +1, and -3, and those are the x-intercepts. Each has a multiplicity of simply 1, right? Well, with this one, with 53, you're going backwards by saying, okay, this function, or you could put y equals, either one of those is fine. For 0, that's a little bit weird. We'll come back to that one. Let's do -2 first. With -2, we say that -2, we go backwards to say that the factor would be x plus 2 when related to the 0 of -2. For -3, we say that it's x plus 3. And for the 0, that's the kind of the weird one, we're just going to put one value on the outside and just say x, because if I set it equal to 0, it would be 0, right? So this is the polynomial. It's not standard form yet, though. To do that, we simply take our values and distribute it. So x times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 would be +6. So this polynomial would be y is equal to x squared plus 5x plus 6. However, notice that we still have this x value here, okay? In this, we're going to multiply this by x here by distributing the x throughout. So x times x squared is x to the third, x times 5x is 5x squared, and x times 6 is 6x. So y is equal to that following polynomial, okay? So notice that I just simply went backwards instead of factoring and getting it to the orange. This time, I'm simply going from the orange all the way to the white, okay? And that's kind of how we're doing it there in terms of finding the polynomials. Many of these, like the word problems, if you want to try those out, that's fine. Really, I could hit on those post-quiz on Monday or Tuesday if you wanted to go through some of those word problems, especially the ones on the homework. So just hold tight to those, and we'll go through that. But this is not going to be one that's on the quiz there. Here's the kicker. Here's what I want you to do on, you know the homeworks are due 2.1a to 2.2a. These problems right here are ones that are going to be very similar to the ones on your quiz. So some of the homework ones do take it a little bit deeper. How do you use your calculator and that sort of thing. This is not a requirement, but it is bonus for the quiz. So feel free to do these 5 problems, go through those, and go from there. Just notice, make sure that, like for instance here, number 3, make sure that you put this in order. So if you do like the lead coefficient test and you list the degree, make sure you put, like the degree of this one would be 4. Because of, not 2, because this is the highest exponent. It just needs to be put in order, okay? Hey, I hope this was beneficial for you. I understand that there may be more questions than answers right now because I know that this topic isn't extremely easy, but if you know how to do these 5 and you do the best on your homework, we will go through those questions possibly this weekend in a study session, or I will also do that possibly on, well, I will definitely do it on Monday. First 20 minutes, we'll go through those questions together. So go through those, do them, and rock and roll. Rock and roll it and go from there, okay? Hey, have a great day today. We will continue forward, and thank you for your flexibility this Friday. If you want to work in groups with the remaining time, you feel free to do so. Just be sure to continue to work on math stuff and get that done. Have a great day. See y'all later.